is Tarak, and I'm now a principal consultant in the open source DB. So today I'm going to talk about the transaction pooling and so how we achieve, uh, you know, happy path for one of the customer using in a transaction pooling, right? Uh, so this is the agenda. Um, get more out of the database and then other stuff. Um, you know, this talk is most of members in this room so already aware of that pooling, and then so I believe so most of the members are already implemented the pooling mechanism within one of the users or in a productions once or twice in that time. But this talk is more about how we make a happy path to the customer, and how we it's all about my experience with the customer. So when he came up with us, and then having their scaling issue. So yeah, so I'm stating the clear point is so we're not talking which tool is the best solutions or not. So this solution is going to be the best solutions or something like that. But so we'll try to make a point and then get into the basics of the understanding. So how we understand that issue, and then how we analyze that issue. So that's the making a point here, right? Yeah. So I think data is a new oil. So every industry, and then everyone adopted the digital era, and then they are entered into the data. Uh, so every data transaction fast, and then user experiences makes and matters in every business, right? So in this era, so we are always thinks about the data and then data growth. So how we estimating the growth, and then how we make happy. I mean, how we make an user to happy, and then getting the transaction done as soon as. Why we are choosing the Postgres is the as in a database solutions for huge transactions and then data. So the first point is it's in a community, and then the community, and then the handle of lot of the data in the Postgres, and then how it will be follow this, how it will be reliable, how it will be handle the transactions, right? So that's the major thing, and I'm always wondering, like, so this Google Pay and then Phone Pay, so are using in a Postgres, and then I'm always wondering, like, how these guys are handling these many transactions, and how these guys are, making sure so, zero failure, near to zero failure transactions, right? So that's making a point, and then I'm always curious to understand that how these guys are handling the situations, and that's where my interest went into the pooling mechanism. I went to the basic, like, so how the connection will be established to the database, and what are the layers, right? So there is a network layer, so DNS lookup, and then TCP handshake. So this network, so when you are using an SSL, there should be a handshake should be required for the connection, and then TLS encryption and parameters which we set for that. And authentication and authorizations along with an process ID generations is part of that, where our Postgres is in a process-oriented thing or architecture. So then query execution and getting the results for that. So in this, how these connections are impacting the database resources and the infra resources, that's making an interesting thing. And yeah, every time when you connect to the database, so we have that connections use the memory. So of course it's gonna depend upon the work memory, what you set for that. And this can be allocated to all the mates. So when you are dealing with in a many connections, when you are crossing in a limits the connection, so utilization of the resources will be exceed, right? Uh, Large number of the database, yeah, of course. So those large number of database and the transactions will definitely cause the issues with the and potential slowing of the database performance, right? So and how it will be affect the client, how it will be impact the client, right? So every concurrent connections limits that connections, and then every user when you take any transaction, and then when you take uh, transaction will not get in completed, so which which I don't know, it's getting in a request back and then rejected. So this kind of things will uh, always uh, making a bad experience to the customers or users in the who are using the products, right? And you know intermediary component is something why I keep the point here is like so how efficiently we use these intermediary components, like you understand, like the PBG bouncer or a PgHyd or an Odysseys, so etc. So we make sure there should be someone who understand these connections, and then making sure these things will be run in a smooth manner, and then so making sure to give great experience with the transactions. So that's motto of the intermediary components. And yeah, choosing the better option, right? So what's the best intermediary way when comes to the situation, when comes to the transaction issues, right? Well, I I made this slide as a little funny, how we can talk within our friends and how we can chat with the friends in the WhatsApp, right? So we're sometimes we talk with the friends in a straightforward manner, like so whether you know, so it's kind of a question and getting an answer in a single format, right? So my wife is also my wife is also having in the same context when we talking with that. So when I'm working with the when I'm working in an office, like so hey, so are you coming for a dinner or a lunch? Then I'll say yes or no. So there is no other questions will be going to be asking, and even if I ask also, then she will simply ignore that, right? So the way of understanding the transaction and the way of transaction pooling works is in the same manner, like you ask the question and you got the answer for that. So that's the manner. And when you choose what kind of a pooling mechanism we need to use, it's depend upon your workload, and it's depend upon your transaction, whether it is in a short-lived or a long-lived, and then how it will be, uh, you know, rally in a database, right? So when it is in a short leave, then we always go within a transaction pooling. And when it is in a long leave, so we always go within a session pooling, so in terms of handling that. And when you have a frequency of repeating the request, when you have a frequency of users asking the same again and again the request, so then we always go within a prepared statements, and that's where we deal with the transactions. So right, implementing the transaction pooling, yeah, so I made the slides in a manner of understanding so what intermediate we choose. And you know as a Postgres admin, so I always prefer and then encourage to the people to use an intermediary solution, and make sure so you use a robust solutions for using in intermediary tools, right? So PG Bouncer or PgHyd, whatever that's it. And PgHyd is going in a engineering mature manner. So we always talk about the high availability, and we always talk about the when we are dealing with a multi-master, right? So we always talk about the latency, how PgHyd is helping in a latency format. And then, so we uh, always reliable on that, and and you know, how we can always focus on that, how we can use the resources efficiently, how we can you know, make the happy path for the customers. So I'm always recommending that, so tailored configuration of your workload demands, like where your workloads will uh, you know, understanding the workload and where your workloads will be lives in the database, and so on forth. Um, yeah. So this is the case study. One of the customer, right? The customer is a financial customer, and then they came up with us. Uh, they figured out the application scalability. So they already you know, scale up the things. So they are already using an AWS EKS as Kubernetes pods. And whenever the tenant came into the picture, then they'll spin up the multiple pods, and then they're running the applications for them. And it's a SaaS platform. They deployed that, and but they were not able to, you know, uh, uh, scaling the database, right? A database, database, you know, infra. So it's day by day, their business is getting in a getting bigger day by day, and then they are spinning the pods, and then they are connecting to the database. But workload is getting high, but they couldn't able to figure it out how to handle those workloads, right? They're spinning the things, and then they're connecting, and they're managing the strings. So sometimes it's getting when peak load, so that sometimes they're facing the issue within a DB restarts, and then sometimes they're facing the issue with the resource utilizations. And these situations, so they came, and initially they sorted out with an increasing the hardware. They made some changes, but they couldn't able to figure it out as how they can scale the things. And that's where we plugged in, and then in the first meeting, so we, yeah, thank you. In the first meeting, we try to understand how their workload is, and then try to understand how they're storing, right? So they are getting in a data from the different sources and then different formats, and they're processing that data and then putting into the MongoDB. And yeah, when we talk about the MongoDB, I think I would like to MongoDB, and then they're processing uh, the processing metadata they are storing in the Postgres. Uh, uh, that's where they are using in a Postgres. And yeah, so I'm very curious about the next talk with the Mark. So he's talking about that how we can handle the MongoDB workloads into the Postgres, right? So that's where I'm also very curious to understand that, and then implementing this with the manner. And the metadata we understand in the second meeting is it's in a short-lived transactions. It's a CRUD operations, what they are storing in the database, and then we realize that. So that's transactions. Pooling is the solution, and then we pitched them, and we pitched them, and then we, you know, told them, so this is what it will give us in a solution. And this is what the analysis we done and the solution, right? So as I said, so we understand that transactions are in a short-lived transactions, and and we implemented the PG bouncer with the transaction pooling. That's where we address the issue. That's where we achieve so that there are almost 10K application connections, more than that, so 10K application connections with 750 MAC connections in the database, right? This is in a hardware of 64 GB with an 8 core, so that's where we achieved that. Yeah, so this is what the success criteria we achieved. And They were an around uh, they were an around 8K plus transactions. So they had an max transactions, and at the peak time, and we make sure so that we achieve that within a 10K, and then so we consider that the future transactions will also in place, and then we uh, try to you know uh, try to make the connection failures as a zero, right? So that's where the our success criteria has been achieved, and customer is very happy, and then that's in a kind of a happy path, right? But when we sorry so but when we go to the implementing the PG bouncer, so we always internally discuss this, so why we have to go with an PG bouncer, why not an PG cat and another sport. So at the time of we implementing the solutions to the customer, PG cat is in a um, engineering mature state. So some of the people are using in a production, and then we realize, and I mean somehow, so we already tune the kernel parameters for the PG bouncer, so at an page level and then other stuff. So that's why so we took an option for an PG bouncer, and then we implemented that, and yeah, so uh, that's also we succeed with that, and yeah, so so we bring the cost effective, and then yeah, so that's it is. Um, yeah, there may be in other solutions will be in a will be uh, will be in a great solutions for this criteria and then for this problem statement. But yeah, so we took that, and then we implement I mean, so we always focus on that as a happy path of the customer. So that's where we're heading into that. Right. Some of the references, like so where we I prepared this uh, uh, you know slides, and some of the content I copied from the Prisma. So that's one of the good blogs. So I understand about the connection pooling. So why we how it will be happens at the starting level, like so what's the network layer and how the handshake will be happens in this blog. So yeah, right. So this is all the story about the transaction pooling, and yeah, thank you everyone. Yeah, we at the post PG bouncer level, OS level, so we made some changes at the page allocations and in user page allocations at level. It is a proc level. Why is the PG bouncer is the question? Uh-huh. Okay. Yeah, I mean, uh, uh, yes, that's a make a point, but I think so we never ask that as why you guys have went into the Postgres, and then so what's back and forth about that. Yeah. Yes. Mm-hmm. Mm. Mm. Right. Hmm. Right. Mm. Not really. Abs- As a thank you. Thank you, Srini. Yes. E- Application side, so no, they are not using. Um, I'm not sure. Correct. Mhm.
In your case, you are dumping the data from your application to like kpod or means pod or anything to the database itself. So if you are using those things, you are creating so many connection, like pod is creating connection and everyone is creating connection. So instead of that thing, you can have a batch kind of thing in the DynamoDB, which can put your thousands or 10,000s record at a time. So you don't have to worry whether it will make a connection, one connection, 10,000 connection. You don't have to worry. Yeah, yeah. So means in my case, like those kind of scenario, database will not work. Maybe like MySQL will also not work, or some other database will not, because they know the Postgres is there, or some means if you are the earlier database is SQL Server or Oracle, they have written. But now in the modern day, when you have this kind of database is available, we can always go for a another approach. because it is like a microservices. Microservices, for microservices you have another database, which can be, means I'm not saying the PG is good. PG is good when you have the entire application and interconnections, like joining the table or getting the query faster. Means for those scenario, the PG means Postgres is good when you are having the large system. But just MongoDB is there, and then one more database just to store the metadata. Maybe like a debatable. So that is why I'm saying. Yeah. So if uh, there are ways also, when you want to join the tables, large tables, you can use Kibana. You can store data into S3, get it query from. Yeah, I agree with you. But there are like a patterns also. It's how, what kind of query you are. Hmm.
You're restricting the number of transactions to a database. And the sharding happens at the application level. So if you want to query customer starting with A, go to database 1. If you want to query for some other customer like starting with P or something, go to database number 3, something like that. So that way, we can handle the number of transaction volumes, and performance also is quite good. So that is one way which we have done for one of our clients. Yeah, that is there.
Yeah, so it's an OLTP systems. Yeah, querying is. And we can do that.
Waste the resources. I can quote Simon Rigg's last work that he was trying to work on something like if Postgres process waiting for some work and if somebody else coming up and waking it up by setting a latch or something. So that's going to take power, right? That's going to consume some power, electricity on the server and some other resources as well. So he's trying to optimize that. As I think that's what his last work was. So fortunately, I was involved in that too, and that work led to, if you know this, promoting a synchronous standby. We used to have a signal file to be mentioned in the data directory, right? We removed that mechanism, and now you just need to run a SQL function to promote a standby. You don't need to restart the server, or you don't need to wake up a process to read the file that you specify in your data directory. That's one side of thing. At that level, we are trying to save on resources, and the other side of things is like we have spin locks, a lot of spin locks specified or being used in the code. We are slowly getting rid of them by using atomic variables. Spin lock is nothing but your process will be waiting or consuming resources. But if you go with atomics, the hardware instructions can help you out there, not consume the resources. So it's just trying to correlate with what the hardware costs, something they upgraded their hardware to handle these transactions. So I'm just recollecting the work that we have been doing.
Thank you, Bharat. In how heavy are these connections, right? In the peak time, so they are going in around more than a 7K plus connections. So, so before before using the major problem, so they came up with us is um, exhausting the connections, and then so system resource utilization. So that's a major thing. And around they are taking that transactions when the peak time, so transactions are taking in a second sentence. So what they consider. Right. 50 for that, for each. No. Thank you, everyone.